Welcome to The Explainer. Today, we're tackling one of the biggest walls holding AI back. We're going to dive into some fascinating new research that suggests a completely different way for AIs to think, to remember, and to solve really complex problems. Let's get right into it.
You know this feeling, right? You're deep into a conversation with an AI, laying out all this context, and then poof, it just forgets a key detail from 2 minutes ago. It gets totally lost. And that's not just a minor bug, it's a symptom of a really deep fundamental problem that even the most powerful models have.
So, what's actually going on under the hood here? Well, it turns out that all of today's big, large language models, the LLMs, they share this one fundamental built-in limit, and it all comes down to how they handle information. This really shows you the difference. On the one hand, you have how AIs currently think, linearly. It's like one long, tangled-up string of words. Everything just gets added to the end. But the new idea is to think hierarchically, kind of like a branching tree. You know, the way a person would actually organize a big project, with main goals and smaller subtasks. See, that linear, unstructured way of thinking is what creates the dreaded context limit. The AI has to keep the entire history of the conversation in its head all at once just to figure out what to say next. So as the chat gets longer, it gets completely overwhelmed. Its ability to reason just drops off a cliff, and it starts forgetting things. It's like trying to write an entire book in one single massive paragraph. It just doesn't work. Now, developers have tried to put band-aids on this. They build these super complex multi-agent systems, or they try to squish the context down. But these are just clunky fixes. The multi-agent systems add a ton of complexity, and compressing the context means you risk losing important details. And maybe worst of all, it's incredibly expensive because developers have to pay for the same information over and over and over again with every single step. And that brings us to this new way of thinking, which is laid out in some really brilliant research from folks at MIT and Subconscious Systems. Instead of trying to patch the old system, they're basically saying, let's build a new one, inspired by how our own brains seem to work.
The whole idea is captured perfectly in this classic riddle. It sounds like a huge, impossible problem, right? But it becomes dead simple when you just break it down into high-level steps. To plan the project, you don't need to know how much the elephant weighs or the exact temperature of the fridge. You just need the steps.
And that is the key insight. The AI is taught to see a problem not as one long straight line, but as a tree of subtasks. So it works on one small piece, it figures it out, it comes to a conclusion, and then, and this is the magic part, it can forget all the nitty-gritty details of that subtask. It just hangs on to the conclusion, which frees up all this mental space to focus on what's next. This whole process works because every single task follows a super structured format. First, the AI has a thought, where it analyzes what it's done and plans the next move. Then, it might decide to use a tool, maybe search the web or something. If the task is still too big, it can actually create new, smaller subtasks for itself. And finally, it writes a conclusion, summarizing the result for all the future steps. It's basically acting as its own expert project manager.
Okay, so how do you actually get an AI to think in this structured way? The researchers created this co-design system, a kind of dynamic duo that works together to make this whole thing possible.
First up, you have TIM, which stands for Thread Inference Model. You can just think of TIM as the thinker. It's an LLM, but it's been specially trained from the ground up to see problems this way, to automatically break big challenges down into that neat, structured tree of tasks. And TIM has a partner, TIMRUN. This is the assistant. TIMRUN is the engine that actually executes Tim's plans. And as soon as Tim finishes a subtask, TIMRUN swoops in and cleans up the workspace. It prunes all those unnecessary details from the AI's memory, freeing Tim up to put all of its brain power on the next problem. It's what effectively gives it an unlimited working memory. Now, I know this all sounds great in theory, but the real question is, does it actually work? Well, let's look at what happened when they put the system to the test on some seriously tough benchmarks. So here's where things get really wild. On these difficult math and reasoning problems, the system that was forced to prune its memory, to forget details, actually got more accurate
By forcing the AI to focus only on what was truly relevant, it actually got smarter and it made fewer errors. Think about that for a second.
And how much memory did it prune on that Amy math task? A staggering 64.1%. So it's not just more accurate, it's way, way more efficient. It's getting a better result with less than half the memory. That is a huge deal.
This also makes things so much more efficient. You know how normally when an AI has to use a tool like a web search, it's this slow, clunky, back and forth process? It costs time, it costs money and latency. Well, TIMRUN handles all of that in one smooth internal step. This gets rid of those network delays and stops developers from getting charged for the same tokens over and over again.
And check this out. On a really tough research benchmark, a relatively small 8 billion parameter TIM model without any complex agent stuff built on top actually outperformed a massive frontier model like GPT-4o. This just proves that a smarter architecture can punch way above its weight class. It's not just about being bigger.
So, what does this all mean for the future of AI? This isn't just about a slightly better model. This is about unlocking a whole new frontier of what's possible. It all really boils down to 3 huge breakthroughs. First, you get virtually unlimited long horizon reasoning. So, goodbye goldfish memory. Second, AI inference gets way faster and much more memory efficient. And third, and this is a big one for developers, you can build these incredibly complex AI agents with what is basically a single simple command.
So ultimately what we're looking at here is a potential shift in how we build AI. For years, the main path forward has just been bigger is better. Just make the models bigger and bigger. This research suggests there's a different path, building AI that's smarter, more focused, and more efficient, right from the very beginning.
And that leaves us with one final, pretty amazing question to think about. If an AI can perfectly manage its own attention, breaking down enormous challenges into small, solvable pieces, and it can keep that focus for basically an unlimited amount of time, what kind of problems could it solve? What could it build? The possibilities are truly exciting. Thanks for tuning into The Explainer.